Hello everyone, this is Mahima here to explain my third experiment in my Unix and Linux lab. In this, we'll be mainly focusing on looping and branching structures. Some of the looping and branching structures I have used for this experiment are for loop, while loop. So, first of all, the first program I have made here is Armstrong. So, an Armstrong number is that, for example, if there is a number 145, then the sum of the cubes of all the digits must be equal to the number itself. That is 1 cube plus 4 cube plus 5 cube must be equivalent to 145. So over here I have created 4 variables within which I have computed the modulus followed by the division and again the modulus of the resultant of the previous variable, and then I have divided it again. Then in the result I have made use of, as you can see, cap symbol, which is used to compute the cube. So here I have computed it, and I have checked if those two are equivalent, then my number is an Armstrong number, else it's not. So if we compile this, you can see this. Now let me put a number 145. You can see that it's not an Armstrong number. Let me try an Armstrong number. It shows that yes, it is. Now for my second one, I have to check if an input number is a prime number or not. So here I have created this. As you can see over here, excuse me for a moment. Yeah, as you can see over here, first of all, I have prompted the user for the number, and then I have created a count variable, and I have initiated it to 0. Now I have run my for loop following from 2, that is the first prime number, till the half value of the number that I have inserted. So over here, first of all, I compute the value of the number and the modulus of the index value, which will start from modulus of 2. And in the end, I check if it is exactly divisible by that or not. If it is so, then I have incremented my count variable by 1, and then I break it. So over here, as you can see, I have ended my if condition using the reverse of if, that is fi, and for a for loop I have ended it using a done keyword. So over here I have checked using my condition as if the count is equal to actually 0, which means if there is no changes at all, then it is actually a prime number, else it is not a prime number. So when we compute this, or when we compile this, let me enter a well-known prime number. It shows that yes, it is. Now let me check for a non-prime number. It shows that it's not a prime number. Now for my third program, I'm supposed to check if the input number is perfect or not. So for that, I have my program. So as you can see over here, first of all, I have taken two variables, I and sum. I is equal to 1, sum is equal to 0. Now here I have made use of a while looping structure. This is how we follow the syntax for a while. While keyword followed by a space, and then we have a square bracket followed by a space again. Indirectly, I would like to say that each and every part of the loop has a space before and after it, as you can see over here. So hyphen LE stands for less than equal to, and here as you can see I have checked if I is less than equal to the computed result of the number divided by 2, and then within that I have a do keyword, which means once that loop is getting satisfied, then I need to do this operation, and I have checked if n modulus of I is equal to 0. Then I would form the sum of it. Then I have incremented I every time, Once it is done, I give the keyword done. Now I check if the sum is equal to n or not. If it is so, then it is a perfect number, else it is not. So over here, let us check. So let me enter a number 6, that is a well-known perfect number. Yes, it is. Now let me enter something else, maybe 12. Sorry about that. 12. We see that it is not a perfect number. Now after that, for my next question, I need to print the grade statement of a student. This is basically based on the marks. So I have my program here. So let me explain the code for you. I have prompted the marks from the user, and then I have checked based on each mark. That is, if the mark is greater than 90, then the grade point would be O, that is outstanding. If it is between the range 90 and 85, so as you can see over here, I need to combine two statements. For that, I need a Boolean operator, that is AND. So over here, in order to give AND, you need to give it as hyphen followed by A. In a similar way, if you'd like to give OR, you can give it as hyphen followed by O. So here I have checked all of these ranges, and based on each range, I have provided these grades. At last, as you can see, I have given else followed by nothing but just a statement, which means if none of these is getting satisfied, then this one by default would get satisfied. So let us compute our code. So first of all, let me enter the least mark, that is maybe let me enter 12. So it shows that the person or the student needs a reappearance. Now let me enter it as 100. We see that it's outstanding. Now for the next program, I'm supposed to print the electricity bill for the units consumed. So in this, I have done it based on my units consumed. So as you can see over here, first of all, I have prompted the user to enter the number of units consumed. So over here, based on that, so as I was telling over here, if the unit is greater than 50, then we multiply it with 100, and then if it is between the range 50 and 40, then I multiply it with 70. If it is between the range 40 and 30, then into 50, else it is multiplied into 20. So when I compile my code, let me enter it as 12. So we can see that 12 is the units consumed and its cost is 240. The same way, if we go for a higher one, maybe let me go for 1 to 120, then it shows that the cost has been increased because this comes under the category of more than 50, so it has been multiplied into 100. Now for my next program, we have to find the factorial of a number. So this is my code. Over here, first of all, I have prompted the user for a number. Then I have a variable fact that I have equated to 1. So over here, I have run my while loop, and I have checked till the number is greater than equal to 1. So over here, first of all, I have my fact. Initially it was 1. Now I'm appending a value to it, that is the expression result of the value fact followed by the number that I had entered. So initially it will give us 1 into the number that I had entered. Then after that, num value is getting reduced by 1 every time. As we know, for a factorial, every time the value gets reduced by 1 and then gets multiplied. That's what happens over here. So when we look at our output, let me enter 5. We can see that the factorial comes as 120. Now after that, I'm supposed to print the Fibonacci series for a given number. Fibonacci series is like a number is obtained by adding 3 numbers preceding it. So over here, I have my code. So over here, I have taken 3 variables, each I have equated to 0, 1 and 2. And first of all, I'm just displaying them initially. Then after that, I have a for loop starting from 3 because it's my next number till the number that I have entered in the beginning. And every time I gets incremented. So over here, as you can see, I have added that fourth number. I have equated that fourth number as the sum of the preceding 3 numbers, and then I display even that. After that, I am appending n1 as n2, n2 as n3, and 4 as n4. So in this way, every time each number is the resultant of its preceding 3 numbers addition. After that, for the last question, we are supposed to print the sum of squares of n numbers. So let me explain the code. Sorry about that. Yeah. So over here I have taken two variables, sum equal to 0, I equal to 1, and here I have checked till my I and m are lesser than equal to. I will keep doing this. First of all, I have found out the square of the number, then I have equated it to the sum plus the square, and then I is getting incremented by 1 every time. So let us compile the code and see. So let me give 2 first of all to start with the least one. So over here we can see that it satisfies because it is 1 square plus 2 square, that is equal to 1 plus 4, that gives 5. So that's all for my experiment. Thank you for watching.